Hey, we're live. How's it going, everyone? We're doing something different today. We're doing some vibe coding. We're doing an experiment. An experiment I started on Sunday night, which was, can we make a fully working game engine in 1 week? So we're going to be utilizing Claude, not Claude. We're using Gemini. Yeah, Gemini. So we're going to be doing pretty much code review of AI code as we kind of shift this thing towards an actual direction that's going to make sense. And this will be more of a, a sit down and chat stream as I chat about like why I'm doing this and then what our intention is with this and vice versa. And I'll give a little tour of what I've already implemented because I have a lot of the Vulkan stack pretty much done over the last few days. We're just adding multiple lights, expanding the uniform buffers, adding in our individual lights. There's going to be, this is still Forward Plus, but we're going to change it, and make some changes to everything pretty much, do some testing. So this is Raven, and it's a fully working Vulkan game engine. What do we have? We have a skybox with some basic shader support. We've incorporated the Jolt physics engine, so we do have Jolt in here, right, doing its thing. Ignore there's only one physics body there. Right, we have a skinned mesh renderer, we have some animations. The animations are absolutely terrible right now, but most of the pipeline, is pretty much working. We have a normal buffer. Event rate albedo, working on ambient occlusion. We got to do screen space ambient occlusion, but right now just getting ambient occlusion in from that sampler 2D from the actual models, pretty much a bit of a win right now. And so what I've been working on with this is making it so we can start serializing some of these materials. Hey Astron, welcome to my 4-day experiment. Let me bring this back to lighting real quick here. So like we have our 2500 cubes in the scene, which have literally no performance at all because the whole UI framework. We also vibe coded from scratch. Everything is from scratch, other than the libraries that I'm actually using for this experiment. So like all the the gizmo support fully works. Right, we have our we have our lovely gizmos, for rotation, pitch, roll. There's some cool stuff here. This is pretty neat, but I copied from Godot a lot of the. Is this Godot or Raylib? Not even Raylib. This is lower than Raylib. Well, not lower than Raylib. This is 4 days of using the library. Let me tab here real quick. So this is silk.net. What is silk.net? It's a collection of packages. So we have just Vulkan, Shader RC, some of the SPURV compilers, an input library, a math library, and a model importer. If you're familiar with Ascent, it's pretty much what it's using. And for audio, it has OpenAI or AL, which is what I'm using. For audio, there's no documentation at all, other than setting up like chaining. But we've pretty much done all that ourselves. And so this is like some of the cool things about this engine that I've already built. So I want to show you this. This is kind of neat. This is what we can't do in Godot, just as an example, right? So ignore like some of this shader material stuff that I'm working on here, but let's go and split this in half. Let's see. I need a quarter screen. Let's see if I can kind of. No, I'll just make it tiny. I'll just prove my point. So So what I'm doing, so I'm not changing. I'm not closing the engine. We're going to keep the engine up. I'm going to keep the engine over here. We're going to come back. So we still have our engine up. I'm going to go to the scripts folder. Check this out. This is neat. So here, if we go into our little scripts folder, we have a default rotator script as an example. So these have some export properties. We have a speed, a color, and a message string. And we have a default on update that I'm overriding, right? And this, all we're doing is we're pulling the game object rotation because a Raven script must attach to a game object. It can get the game object through, you know, the abstraction of the Raven script. And then we're just rotating it. That's all we're doing on this update function. But this is what's neat about it. I'm going to right click on scripts, and I'm just going to, like, while the game is still running, I'm going to right click and I'm going to create, you know, okay, it's Asteron. Okay, .cs. Okay, let me just, so we get spelling right. And I'm just going to steal the signature of this class. Right, so I'm just creating a totally custom class. I'm going to create some exports. So like a string, an int, and a float, and it's all right here, and a color. Let's do an export color. Right, so a color value. And maybe on update, I don't know, but let's just like, so we've made this thing. Right, here it is, right? It's auto, like everything auto hot reloads. So all while I've made this thing, I can just go to the root here of this game object. I can add a script. Here's the rotator script, which is running if I resume it, right? With all the properties, the color that's been selected, let me move it over. Right, so here is rotator with all of its serialized properties. And if I go add another script, there's Asterion, boom, with, you know, float value, message, int value, string value, the color value for cyan. And this just hot reloads everything as I'm typing, even if I change the values. So if I, you know, I'm just sitting there and we're like, okay, we want this to be like cool color instead, and I save it, it immediately updates to be cool color. So everything is live, and this is an important early implementation. Not in C# land though. I mean, in GD script, that kind of makes more sense. It's kind of the same context here, right? The neat thing is like this, I don't have to stop the project. You know what I mean? I don't even have to stop the game. I can just, you know, do its own thing. So the reasoning now for kind of, let's remove these rotator script, and we'll remove this one. So we're kind of back to where we were, and I'll just pause the game. Is that I want to be able to kind of, you know, once again, we're kind of building up an entire, you know, Vulkan renderer, so, you know, that takes time. Just like right now, it's working on it right now. You can now use multiple lights. We've expanded FDOs, so every time we do something, we're gonna just check and make sure that, you know, we can actually add, you know, like another light to the scene, and we test it. But if I can make, you know, AI be able to communicate with the engine in real time because it can code for the engine in real time, then its ability to edit the script, immediately pull the response from the console of the actual engine, its time to iteration of try code, pull response back, iterate is rapid because it's fast. It doesn't need to stop the engine to kind of do that. If it crashes, it'll just fix the crash, and then so that's kind of the little idea. So it can help. So who's coding this? So right since Sunday afternoon, this is only day 4. All I'm using is Gemini 3 Flash preview. That's it. Just Gemini 3 Flash preview. Not GPT-5. Not nothing crazy. Not using Claude. You know, we're just, you know, going through the very traditional, see what the AI makes for recommendation, implement, review, push, same thing, right? So that way I can focus in this, you know, we're only going to give, like, it's a week. This is like a week project, right? We're just spending a week. My hope was that as a meme, like, this would stop. You know what I mean? No, it's Copilot. This is all Copilot. right? You install Copilot, and then you, depending on what license you have, you know, you can pick from your models, right? So this is just simply $10 a month Copilot, and I have access to a load of this stuff. But the meme was, this would only get so far, and then it would fail. It would lose context, especially dealing with Vulkan. But what I didn't expect is for it to not fail, right? You know what I mean? I expected at some point it would run into some problem that it would need help, you know what I mean? That it wouldn't solve. It would just fail to continuously iterate and reach the point of, you know. But so far, you know, so good. You know, so what we want to, so there's a few things we want to do here. And I want to use this. So what I've done in this engine, to get things kind of started, you know, I wanted to use, there's a paper published a day ago about infinite context. Cool. But so we know we're using Jolt and Godot, so we're using Jolt here. So all of the physics simulation settings I've made are exactly the same. Cool. Right, but I want to be able to test certain compute shader functionality. So what I've done with you know, this thing, I've set up the whole swap chain. Everything is now working. I have a basic ECS system, so we have it's running a custom ECS test where we just have, like, you know, some very basic components. We have a double precision vector 3. We have a double precision velocity. Yeah, no worries. And we're just like making sure that, hey, like after X amount of time, has the system updated, you know, the precision positions correctly, just kind of like flying a virtual ship around. And then other than this, like other than the skeletal stuff I was working on, I also have a compute shader. So I created a whole compute pipeline. Right, so we have a compute shader. All it's doing is doubling a bunch of values, and then the test will, you know, will be successful if the compute shader runs. But I want to like use, like, I want to be able to go into shaders as an example and like edit the shaders in the engine and have them like live recompile in the engine, right? So it's just kind of like as fast as it can fail is kind of my mindset on this particular game engine, which I'm just coining Raven. And whether it becomes a shelved monolithic project that doesn't do anything, it doesn't go anywhere, it just becomes a thing, or if it grows into anything, if it has any potential whatsoever, if anything, it could be a very good framework to do some testing on, right? The fail fast engine. Yeah, that's like the thing, right? Like, how fast can you make this run code and come up with a result, right? That's the you know, the idea. So we have gizmo support, physics support, you know, lighting, directional lighting, shadows, like all the basics. And we need to test the lighting. I just literally told it to finish setting up the UBO buffers for the standard shader. So here, right, we have our light data coming in, so position, color, direction, and parameters, right? And then we have our UBO, so we have our uniform buffers. So this is like light space matrix, our light count, time for anything that needs it. So these are like sent to all the different shaders. And then we have our, this is like what I call them, like my standard, you know, pipeline or standard material. So we just have our normal emission, metallic, ambient occlusion, you know, our shadow map, and the push constraints for emission, rotation, AO, like, you know, whatever we're feeding in. And, you know, very basic GGX lighting, you know, this is all very, you know, industry standard. And here's our main loop for our normal map. And this here is what we're working on, is for multiple lights. So depending on the light count, it'll go and, you know, actually like take the data and you know, set up our everything, fire, ambient, occlusion. These are for rendering, so all of these modes here with the, you know, looking, you know, just driving all of our normals and normal maps into get away. Right, so we only have a couple of normal maps like in the engine, but just on our little GLB test. And the shadow, right now the shadow app, like the shadow maps, very low resolution. Right, so what I would like to have is like an example of compute. So maybe like an ocean shader. Right now it's just like a sine wave over fragment and a vertex wobble. And because this is only a plane, we don't have a lot of primitives in Raven, right? Like our primitives are literally like a cube, right, and a plane and a wire cube, which is what we're using for the selector AABB bands. And so, but the Gizmo AI did a really good job creating the Gizmo arrows. I think the Gizmo arrows pretty good, right? Same with like rotate and scale, right? Like pretty good, right? And they're just like a 64. They're 64 verts, right, of a circle, which is pretty much enough resolution, and they don't. Yeah, it doesn't matter how far away you are; it still keeps the same scale. Makes it easier to actually rotate that way. So we need so in our we need to get our file menu moved to the very beginning, and we need a file new which will clear the scene. Right. So we need to do testing, of course, on the changes to the. Let's see. So our light count. Let's do the review first. Just want to make sure that we're good. So all we're doing is adding our light count and light data. And this is just a default, so it looks like by default we're supporting up to 16 concurrent lights, which is fine for the time being. Because we're kind of like, you know, like my goal is not just to vibe code and engine. You know, I want to learn from this, right? I can rip all this apart and adapt it to, you know, any test case needs. Yeah, then we have our ID. So for our source path, what are we using our source path for? Oh, the serializer. Okay. So when we're saving our scene data, that's our material path as source path for the material itself. Okay, that's fine. Okay, yeah. So I don't know if I like the word naming for source path. Then we have our point light and our spotlight. As by default, it's kind of a directional light. And then our serializer that was created. I don't know if DTOs. I don't know if I like DTO. Like in web, DTOs are fine, but not really feeling. I don't know. Maybe it's fine. I mean, it is like data, and it is the serialization of the data. So, you know, by definition, I guess it is a DTO. But and this is fine. The hierarchy is fine. So this is fine. So we've added. Yeah, so we're going to just take our PR here and we're going to use it as our commit message. And then we're going to move on next. So we're going to just, make the election changes. Add to the main menu. So add file first. Have the first option now be create new scene. Which will give us an empty scene with nothing in it. Right? Because this will take a while. While it's doing its thing, right? We can be productive, you know, people. We can play around with Blender. We can chat. We use the AI's implementation time, you know, for our own productivity, but then we also want to code review every single thing it does. Right? Because when I'm going through this and my brain is, oh, okay, like, you know, there's still things from the original like menu options that I would like to move into the it's already an editor UI now, so that's fine. Right? So Yeah, and there's an abstraction here I would probably like to do as well, which is the idea of creating a menu. Because the way the UI system works is it's built very similar to DRM GUI, where we just have a UI singleton that creates, like when you create a dropdown, it binds a callback as if UI.dropdown file with all the references, right, and like width and height. Then it'll, you know, like if we've created a dropdown, then these are all the options, and if you select them, right, then of course we're actually doing the action. So you're kind of just literally subscribing the action, right, on the return type of it being true. So it's already done it. So that means we've already had it clear on the world and the scene, which is fine. So clear the game objects, remove the selected object, and clear the ECS world, which is fine. So this is great. So refactored and we'll just see how that was. We'll see if this can be as fast as I can, you know, architect it. Like if the AI can catch up to myself while I'm just sitting here architecting design, then like that would be great. Right, so now we're in, we have our file menu, we have create new scene. There's a bug, I don't like how this background of the drop down itself, that's why the drop down should probably become its own menu system instead. Because it works here, like lighting is fine, menu is fine. I think all menus should always become on top regardless. So the glyph or the buffer that gets drawn, like our little kind of mesh, needs to kind of scale, because what right now it's based upon the length of the actual file and not the actual item in the menu. So we need to make it so make sure the drop menu itself can be set with a custom width, unless we can dynamically expand the full menu width by character length of the menu item. Okay, so depending on the menu item length of the drop down, I want to turn these into icons as well. Then auto expand it, and then also make it be on, you know, always on top. Right, so now like in the UI context, what we'll be doing, so in our review, just move this over, because we need to be able to see both. Right, so what I'll do when I am vibe coding is I'm looking at changes, right? I'm like it doesn't matter who writes the code, right? It's the same as if you had a team member working on the code. Just your team member is a video card running in your basement type of deal, you know? Right, so taking the drop down and kind of going over each of the items, right, and then expanding out an IW, then we dynamically set a width. So if the width is less than 0, we have a max width based upon the initial label, and then for each of the items we expand out that max width. So this is fine, like I wouldn't write this any different. And you can still override this by passing a positive value. In other words, if width is any value at all that we've manually set on the drop-down struct, if we set a width, then we, you know, we'll only expand it if we're kind of greater than that. So let's just see how that runs. And then for the next step of this, you know, we also want to make sure that it's always on top, because they're not really rendered on top. They are for context menus, so like this is a context menu that I've created, right? For create material, create folder, we're gonna add icon support for it. Same here. But as far as like file, see, this is nice, right? So now this will grow dynamically to the, you know, create new scene, and then boom. But it should have also got rid of all the physics objects, which ironically enough it didn't. Because these, these still have references. So we'll fix that. Make sure all the physics objects are being cleaned up. Okay, they're still in use. And we want to ensure that this is always on top because it's not. So like, you know, same thing. So a drop down menu should always be on top. On top, similar to a context menu, because that'll force the AI to load the context menu to get the reference from the context menu to compare the context menu. Right? So this is what we're doing here in advance now. So we're adding a tiny border of separation. And we're pushing a clip. Okay, yeah, cool. So we're enabling our overlay, pushing the clip. Based on our screen width and screen size. And then we pop the clip, enable the overlay. What are our minuses? Well, there's visible. Yeah, while that's doing this thing, let's do some review. An ornament. What's the O? Okay, ambient occlusion, roughness, and metallic. I wonder if we should really actually utilize ORM maps. Maybe we should have the option of both. Have you played around with anti-gravity? Someone showed me that earlier, IPO. Looks pretty good. We killed the engine. So physics objects, physics cubes created via placeholder statement. Don't remove, unclear. And let's review those changes that I did first. So we're using like a clip map now in the right click. So now the right click itself right? So this should be the same. So these drop downs should now be completely on top and fast. So if they're off screen, so like if we come and like make, you know, this be a thing, anything that's not being rendered right now is actually being clipped. So we gain performance. So that's why the whole UI, at least the UI so far, you know, is running at stupid frame rate. Even though, so now let me just resume our Jolt simulation. Jolt is good. Right. So we have all of our inspectors. And now let's just clear, let's just stop the scene real quick and create a new scene. Okay, yeah. So we're not clearing up all of the physics system buffers. Because I think the physics system is not being cleared. Yeah, so it'll probably need to do a query update to the physics system. So the physics manager itself, where we're incorporating Jolt, right? We'll need to kind of go through and clear all the bodies, which is really just pushing null through the, you know, because I don't think it, like, when we're updating the game objects that have bodies, yeah, we need to remove body ID. One way is to get all the body IDs removed. However, Jolt doesn't expose any get all bodies to the sharp wrapper in a single call somewhere. We can use the body interface to iterate if needed, but since we're clearing the whole scene, we can just destroy and recreate the physics system. Or we can expect the scene to tell us which bodies to remove. Yeah, that's good. Actually, for full clear, it's just supposed. I think we'll just if we're gonna do a scene tree re-clear, we'll just do a reiteration. Oh no! Now we're streaming engine development. You're now making the engine on the stream. Yeah, we're just vibe coding on the stream while we do Blender things antics. It's fine. Yeah, I think the process of just completely reinitializing, but it's heavy. Yeah, we'll probably just remove. We'll just go through and do it the right way, which is removing the bodies. Yep. So we're going to the physics manager. We're gonna make a test scene antics. What are we doing with it? So we got the compute pipeline in, and what I want to do is just have the engine clear itself right now. So we have a load and a save function. We have initial serialization of all the game objects, but I can't really test the load and save functionality or the new lighting system that I just added until you know, we're able to kind of clear the placeholder scene. I gotta fix that thing too. So physics manager cleanup. So we have the ability to now remove a physics body. For scene life cycle, we now have a clear and remove. In the physics manager, we can now clear all the game objects. New scene will now do automated cleanup. And fix the context menu and delete buttons in the HUD to correctly pass the active physics manager when removing components. So I'll also just want to do a .NET. So you fix warnings, we'll run the engine. Getting a 2-minute ad? Why? Oh, why did the show? Why were they not? Oh, I remember. We were gonna do shader material specific, and then we didn't. All clean, no bugs. Let's pause it. Create a new scene. Excellent. Oh, that brings us to something. You're back from the ad? Perfect. You were saying about getting the shader not working. Need it to get the shader work with the engine. Yeah, I don't remember. Okay, so drop the answer fix. We have a new fresh scene. Create a cube. Where'd the cube go? New cube doesn't do anything. I'm gonna check something real quick. Yeah, draw calls one. I want to see like what the other options are for like adding something to a scene tree. I don't think like you have to do it by right click. Like add child node. Is there a way of adding a child anywhere else? I don't think there is, right? You must right click and create add a child node. Control A. Is right click the only way? I think it is in Godot. Yeah. Then we get a context menu of what type of node to add. Love the auto mode. Okay, so so it has to be, well, at least we're using Godot as an example, to right click. Create cube. Wonder why it doesn't work. Maybe because I'm not seeing it. It's not updating the hierarchy. So in hierarchy, what is it? Create cube. also add create light. We're gonna change it later. And then we'll push these changes. And then I think the next big factor is going to be moving all of the resources into a resource manager and just get that banged out into its own thing. So all engine resources can be managed there. So stuff the UI needs, you know, like icons, you know, like there's only a few that I've kind of added. But they don't need to be a part of the engine class. There's a lot of stuff now we're just kind of, you know, breaking out of the engine class, abstracting. So we have that we're invoking an event when we're doing it. Let's add light. I feel like this should actually, you know, add cube and add light should kind of be added to the scene. Oh, and the only reason why it's not added to the scene is because of the materials list. Because we're just pulling a random standard material back for it in the scene. Did you pay for Copilot through Google, through GitHub? So I'm signed in to my GitHub account and my Microsoft account. This is mostly my GitHub. Best $10 ever. Yeah, so what I think the scene, like the scene hierarchy itself, needs to have like a centralized resource, and I think the scene should have the game engine should be telling the scene to add the game object, and it should have those nice placeholder scripts in it. Because we're not getting a success that it actually is creating. Just need to get a couple of tracks. Mm. And then we want an effect. It's also an odd. Maybe like a blaster sound. Blaster sound. Odd. Laser. And does Copilot just allow you to use all those models? Pretty much. Blaster. So, yeah. Oh, thank you. Yeah, that needs to be refilled completely. It's ancient. So let's rename that effect. Um, interface. And Khalil on ambient. Put these in the engine. So we'll throw them on the audio in general for now. Because I haven't tested the audio yet. I want to test all the things that it's done so far. Okay. So we're still fixing all those issues while we're kind of sitting here improving. Because what I want to do is when we double click, like on the editor level, I want to make a play sound function that'll just kind of create a individual sound buffer and just play the sound when we double click. Because it's a great way of testing if the audio effects are actually working. Random bit of debugging. Yeah, so it's the clicking that's not actually registering. We might have like an environment type situation, I wonder. Or a scene environment settings. It might be in our drop down. I think environment should typically just be like a default thing. I don't know if it would need to be like something specific. Also add a scene drop down next to file. That will have a environment, English window, that will bring up a environment settings window. And then we'll look at the option of actually creating in our UI toolkit a checkbox, which is just going to be a toggleable square. We're just going to use the button. It'll be super easy and fast for that to be implemented. Add environment settings. I want to fix this Vulkan errors. Vulkan errors is being caused by the changes that we made to the window. The right click menu, when we decided to make it always on top, and it was doing its clip space thing, it was needs to be cleaned up. So if you close the engine in advance with it being cleaned up, it's going to pull an error. So it's going to go ahead and just fix that issue. Pretty clean, yeah. Need a better way of disposing of. Are you gonna clean that? Hmm. Alright, so the physics queue multi-mesh instance buffer was being orphaned without the disposal when cause oh, interesting. Right, because we just pretty much said, hey, reinitialize these, but it was being orphaned with disposing when calling to create new scenes. So we killed the physics objects, we never killed the meshes. So the leak handle, the size of 3200 bytes, matches the storage requirement of 5000 instance matrices. So we added an explicit dispose of for the new scene, in load scene. Gotcha. And then in load scene, cool. Right, and we're not creating a VK buffer every time we load a mesh. Process node is now using the unique key. Game object no longer disposes the iMesh in its own dispose. Okay, good. And our standard material. There's no metallic. Yeah, where's our color reference? Color velocity. Although we're just using color edit, this just takes in color. So this can actually just be changed back to the color and not a vector 3. Because I don't think we have a way of casting between them. Yeah, because this is now changed to take color instead. Yeah, because I never created a helper class that I like. So color, do color, no. Yeah, much better. Alright, so added all of physics objects total. And by default, Alright, next we're going to add a checkbox, which will be very similar to a button as far as rendering goes. Just a text with a square button next to it. Toggles by color or black or disabled. So we get a checkbox being made. And then we'll add those checkbox options to the UI for the settings. Because what I want next, I kind of want to turn off the skybox influence here with extremely metallic objects that are like maxed out. So like just the option of going in and going to the environment settings and turning off the light that's being cast from the skybox. So just have it as an option. Because I want to create a perfectly black scene that has no light at all. But I still want to have it all, have the right options happening. Boombox is cool. What does a directional light look like in the scene? Oh, just a ray. Just one arrow with a light icon. Gotcha. So add a sun cast shadows field to the environment settings for testing. Let's see if it did it right the first time. Oh, yeah, that's great. It's fine. Totally fine. Cast shadows. Take a look at our shadow buffer. Does this actually work? Nope. Like the Well, checkbox works. So for custom inspectors, well, checkboxes used dynamically for bowls. So in the game object inspector here, oh, we were just using a bool as a checkbox before. Yeah, I like the checkboxes. They're working fine. Wonder what this material. Okay, just added one brand new. Yeah, because we're not changing the albedo. Emission seems to work fine. So does roughness. Oh, it's the rough. Oh, okay, okay, I see. It's because we still have that original material on it. Add a checkbox. We have sliders, we have checkboxes. Missing any other type of serialization. I like the scale up and scale down. Yeah, it's holding over a input. Which is being used for an int bool or double. Or sorry, int, float, or double. When we start holding the mouse, save the position. So we move to the left or to the right. The value will go. Yeah, but it doesn't really have a type, like a line edit. It doesn't really have this. It's just numeric or not. It'll need some data to know like what type of line edit it is. Maybe it's just not a line edit. Maybe I create like a custom one specifically for numerics. Does that make sense? Not really a line. Excuse. See if it picks up on that. Because we have a float edit actually already. Actually, stop. Holding over a float edit. It'll have context. Because it's just a wrapper for a line edit, but it'll just have the extra features. We do a universal drag start, drag in, drag mouse position, that's fine. And in 4 more minutes, like we're gonna go raid someone. Let's chill out for a bit. Checkbox is in. I'll keep this kind of coding overnight. So it's a lot more complexity because you got to handle the mouse over. You have a saver cursor position, hold the mouse, and then depending on movement, increase or decrease the value, and then notify the property changed. Yeah. Yeah, I think all these types can be handled a little bit better too. For the serialized properties. A lot of changes for a small feature. Oh, but it's such a good one though. See, it's so much nicer to just be able to drag positive and negative. You can control the speed at which you, yeah, much better. Good job. Usually. Anyway, we're also going to do the audio thing where if we double click it, it'll play it. And I do want to have that in there just to be able to. So, line edit, numerics. Now be held and drag with mouse, increase and decrease. So in the vault, and when we click on a OG or wave, play the track. This will be the last thing we add, and then we'll raid someone. Because it's trying to do it, right? Asset selected. So it just needs to integrate with the sound manager and just play the sound. Assuming that it can load and that the memory addressing of where we load in these sounds is not messed up. Found the audio manager. Found the audio loader. Because I think we just have load wave. For a riff file, a wave file, an FDM file, and I think it should handle OGG. I'm sure. So this audio loader might need to be adapted. So we gotta play a one shot. So the wave should play fine. One second. Okay. Well, that open AL could play Org Vobis. Can't open AL play Org. Explore Silk.net libraries for audio. Because I'm pretty sure we'll get to do it. We'll do it ourselves. There's X audio, but I thought Open AL. Maybe not. Maybe OpenAL is just for doing 3D, but not necessarily a format itself. Cross-platform. Whoa, I can use XR. Whoa, that's cool. The alternative library we could use just Invorbis, or we could use standard that cause small frame hitching and very large files, a lot of domains, right? Man, there's like one guy, dude, who imports all these packages. This guy, man, RDS 1983. That's created ports of so many like libraries to C#. It's crazy. What else could I use? Anyway, that's it for the implementation of tonight. I'm gonna get ready to raid someone. We'll get back into our normal game dev. probably just over the weekend back into doing. We need to like really sit down and go over some of the station interior stuff. Some of this modularity. I need to approach like the materials. My challenge right now, my issue, is what materials to make these inner walls. Like, you know, I kind of get the idea, the design, the form. My brain is like getting, like, you know, artist block on the type of materials to actually like utilize for it. And I don't know, it's weird. All right, let's end it here on YouTube.